Hello, welcome to this webinar session around Windows Embedded Standard 7 for application developer. This session is presented by Arrow Europe and Adeneo Embedded. Nicolas Vasseur from Arrow Europe is going to introduce all the Arrow Europe services. So go ahead, Nicolas.
Hi, my name is Nicolas Vasseur. I am the Microsoft Embedded Solution Architect in charge of France. My main activity is to support you on the Microsoft Embedded portfolio, especially for the choice of the solution to its technical implementation. The purpose of this set of seminar done with Adeneo is to provide you with a deep technical view on the Windows Embedded Standard 7 solution. To start this session, I want to provide you with a quick overview of Arrow OCS. So Arrow OCS, OEM Computing Solution, is a Microsoft Embedded distributor, part of the dedicated ecosystem put in place by Microsoft to support his customers using the Windows Embedded solution on the field. So my main question is Arrow a classic distributor? No. Arrow provides you with a complete service. Arrow is there to assist you to select, to design, to deploy, and to maintain your solution based on Windows Embedded solution. Our mission is to help you to find the right solution online with your needs, constraints, and expectations. So the set of services we propose is divided in 4 parts. So the first one, training and technical support. We want to help you to design your embedded device. So Arrow put in place a complete set of services to train and to support you. Through our partnership with Adeneo Embedded, who is a MS Embedded Gold partner, Arrow is able to deliver online workshop like today, dedicated training with hands-on labs, consulting services. To support you during all the design phases, you can access for free to dedicated technical support programs. The first level of this program is delivered by the Arrow experts who are trained and certified by Microsoft. If you need a deeper technical support, our experts based around Europe can address you to our support contracts, for example, with Adeneo or with Microsoft. Just keep in mind that those support programs are for free, so it's really interesting to work together. The second part of the service we can offer is the licensing advice. So Microsoft licensing and process need really a good experience and knowledge to work with. Our main mission is to assist you to select the right solution respecting the embedded licensing. This solution must be adapted to the market you are targeting, so don't hesitate to ask us advice to clarify it if needed. If you need more details, don't hesitate to contact us. The third part of the service is the ready-to-go hardware and reference design. So from the board up to the complete solution, Arrow OCS can provide you with a complete set of hardware solutions and added value. We have a dedicated team of solution architects ready to provide you with the best solution online with your request. So we can help you to focus on your core competency rather than investing in the platform development. If you want, in other way, create your custom solution, we have a great partnership with all the main silicon vendors and Adeneo, who has a great BSP expertise, and for us it is the best way to succeed when you want to develop your custom and own solution. The last part, but not the least, is the marketing programs. So we are the first point of contact to give you access to the strong Microsoft marketing programs. Those marketing programs can help you to have more visibility on your market through trade show, case studies, internet communication, and so on. So if you want to access to this kind of program, don't hesitate to ask us. Keep in mind that the MS marketing team is ready to help you to work with enterprise customer, and it's pretty new in the Microsoft Embedded organization. And when we talk about enterprise customer, we talk about customer like retail end customer, Carrefour, Auchan, and so on. To wrap up, WES is your partner to bring the bricks of your solution all together. To support you on the field, as already said, we have a dedicated team of Microsoft specialists based around Europe. So you have on the slide all the details regarding all the people we have on the field. So don't hesitate to contact us. We have a great website, and if you want to have more information, send us an email at the Microsoft at europe.com. So I want to introduce now Nicolas Besson from Adeneo, who is going to deliver this training. So Nicolas, it's your Nicolas.
Okay, sorry, Nicolas, I muted my microphone. So, yeah, so I'm going to do all the technical presentation today. So I'm the Windows Embedded technical leader at Adeneo Embedded. Today we are going to talk about drivers integrations, driver installations, packages installations during startup. We are going to describe the way we can customize our system to remove all the message boxes displayed on the screen, or we can enable filters to protect the file system. So this session is a session number 3 from a set of 4 different sessions. So let's go ahead. So Adeneo Embedded, just a short introduction, is a set of 50 engineers working both in Europe and USA. We have a strong expertise in Microsoft technologies around Windows Embedded Standard, Windows Embedded Compact, Windows Mobile, Windows Embedded Handheld, Windows Phone. And we are mainly focusing our activities around industrial markets, medical, consumer, automotive, and mobility. So we have some awards from Microsoft, and especially a Gold Partner Award since a few years now, and we are deep involved with major silicon vendors like Freescale, Texas Instruments, and Intel. So, integrating drivers. Windows Embedded Standard 7 is based on Windows 7. So that means that all the drivers that are working on Windows 7 will be able to work under Windows Embedded Standard 7. So if you get a printer driver from the manufacturer and this driver is perfectly working on Windows 7, then you will be able to make it working on Windows Embedded Standard 7. All the drivers are 100% compatible. No needs to redevelop a driver, no needs to customize those drivers to this specific version of Windows Embedded operating system. And it's true for all the type of drivers for x86 or 64-bit platforms. Microsoft is providing a set of drivers that are available in the development toolkit. So that means that most of the interfaces that you can find on the hardwares, on the today's hardwares, will be probably supported by the drivers that are present in the development tool. Windows Embedded Standard 7 support the plug and play. So that means that I can dynamically identify the the add of a new interface. My system on boot will enumerate all the interfaces to identify plug-and-play devices. For example, audio interfaces or PCI Express new boards and so on. When you are doing Windows Embedded Standard 7 developments, you are customizing the operating system. But you can also pre-configure your drivers. You can select all the drivers that will be included inside your OS image. So imagine that right now you know exactly the hardware that you have. And in the future you will have new devices to add to connect to your product because of some availability. You will have to find another solutions. So the drivers that will be required for this new hardware in the future is probably not available right now, and you probably have no idea on what will be the type of interfaces that you will need in the future. So the drivers that you will be able to install in the future will be installed at runtime. So that means that your system will run and you will be able to install the driver directly onto your target. So there are different approaches to install a driver. This driver can be directly included inside the runtime image that you are building, or it can be installed later on your system. Microsoft is providing you a tool that will allows you to enumerate the interfaces available on your hardware. Because for now you just receive the board this board is on your desk and you have no idea on what type of drivers are required by your system to be able to run, to be able to allows you to run Windows Embedded Standard on it. So you have no idea on what type of North Bridge, South Bridge controller you have. You have no idea on the interrupts number. You have no idea on the controller for the USB interface. So the manufacturers are not necessarily producing a list of the drivers that will be required for your hardware. So Microsoft is providing a tool named TAP, Target Analyzer Platform, Product Tools. I don't know, I don't remember the name for the P, but whatever it is. Okay, so this application is something that you will run directly onto your hardware. So by booting Windows 7 or booting a bootable CD, you will be able to launch this TAP application to get the list of the interfaces identified by the operating system. This tool provides a PMQ file. It generates a PMQ file. And this file is an XML file that describes all the hardware connected to the target. So that means that this PMQ file is something that you will keep on your side for later development. In this XML file, you will have all the hardware IDs and all the vendor IDs required by the system to identify the drivers associated to the hardware. So that means that this PMQ file is really interesting because it will list all the interfaces available on your system, and therefore your system will be able to find the drivers associated to those interfaces. The image configuration editor, which is the tool that we saw in the previous sessions, this tool allows you to select the features and configure the operating system. From that tool, you will be able to import this PMQ file, and it will go through all the XML entries and identify the drivers that it might be required by the system, and it will automatically add those drivers to your answer file. Remember that the answer file is the configuration file that will be used to generate your runtime image. The ICE tool is using this answer file to generate the package for the installation of your runtime image. Alright, so once you run this TAP tool, you get this PMQ file and you will be able to import it inside ICE, Image Configuration Editor. So what happens if the drivers that I need are not available in the development tools or in the distribution share? This is the place where the drivers will be located. Then, no, don't be afraid. You will be able to add your own drivers inside the distribution share. So if you received a third-party driver for your printer, then you will be able to add this driver to your distribution share. And as this driver will be part of your distribution share, when you will generate your runtime image, and if this driver is included inside your answer file, then this driver will be included inside the runtime image that you will generate with the image configuration editor. So the driver will be added to the main OS image, but it can also be used during the installation of the operating system. Imagine right now that you have a red controller that requires a custom driver because Windows is not supporting that specific controller. So during the installation, you need to enable red on your hard disk to make sure that you have the correct management of the storage content of your hard disk. Then during the installation you can load drivers that will be used during the installation process. That doesn't mean that it will install the driver onto the target in your final image, but it will load the drivers during the installation of the operating system. So that means that your red controller will be visible by the installation tool, and therefore the installation tool will be able to access your hard disk to copy the files for the installation of the operating system. Later, probably you will have to add this driver inside your runtime image to make sure that when the runtime image is installed on your hard disk, then when the system starts, it will load your red driver and then your system will be able to boot. The drivers that you are adding to the distribution shares are drivers that are composed of INF file and probably some additional files like .sys, .cat files. It doesn't mean that it will be an MSI. The drivers that you are adding to the distribution share inside the drivers folder, inside that distribution share, are only drivers that are provided as with .inf file and .sys and so on. Alright, sorry for that. Okay, so once you add the driver inside the distribution share, first to install this driver, to copy this driver inside the distribution share, you have to first locate your distribution share folder on your hard disk. And then inside this distribution share folder, you should find a subfolder called out-of-box drivers. Then you can build your own infrastructure folders, infrastructures to store your drivers. Inside that new folder that you will create inside these out-of-box drivers, you will drop all the drivers files, all the ENF files and all the files that are associated to the driver. And then when you will open up ICE, you will see your drivers in the list of the available drivers for Windows Embedded Standard 7. When you will pass this PMQ file, when the ICE will open this PMQ file that you generated previously, then it will be able to identify the driver for this specific controller and then add this new driver to your answer file. Okay, but not all the drivers are provided into the format of a .inf file. Sometimes drivers are coming as installable packages. So that means that to be able to access the files, the drivers file, you have first to install the driver, which is a little bit annoying. So, two solutions to have these drivers installed onto your final target. The first one is to say, okay, I don't need it right now. I can install my operating system and then install my driver later. This is exactly what I said previously. The second solution is to say, okay, it could be nice to have this driver part of my distribution share, but because it will be easier for my coworkers or for myself to add this driver later in if I want to customize a new runtime image for the same hardware but for a different product. I won't have to do the same actions on both platforms because I will do the action once and all the files will be included inside my distribution share. So there is a way to extract the content of the installable packages. If you are able to extract the content of the installable packages, then you will have access to the source file, not the source files, but the files included inside these MSI packages or installable packages. To perform this, then you can take a Windows 7 machine, and using the tool that we talked about in the previous session, so the Process Explorer application especially, you will be able to see what will be the files created onto the hard disk, and then you will be able to identify the files that are part of this MSI package or installable package. Because during the installation of the installable package, the system will access the registry, will access the file system to drop the files to the correct place onto your Windows 7 machine. So, okay, you get the files. Perfect. Now you have the files, you can drop those files onto your distribution share. Alright, but for some drivers, sometimes it's not possible to extract the content of an installable package. Just because the way it is done. Sometimes the drivers must check the hardware availability, must check some security information, must connect to the internet to get some information, whatever it is. So some drivers cannot be extracted, and then just by having files, you cannot install those drivers onto the target. So the idea for those type of drivers is to say, okay, I have a package. Why should I not be able to add this installable package inside my runtime image and have this package installed automatically on the first system boot? Yes, I have a set of files. I'm installing those files onto my hard disk, and then the first time my system is booting, I have these drivers to be installed automatically. Wow, good idea. So adding those type of drivers is like adding other type of applications, like I don't know, Acrobat Reader, Java Runtime, .NET Compact Framework 4.0, whatsoever. So there is a way to launch what we call synchronous commands. The synchronous commands are actions or applications that the system will be able to launch during the installation of your system. So you can launch synchronous commands at different steps of your system installation. So as you can see at the bottom of this slide, there is a screenshot of the image configuration editor menu with the synchronous commands. So you can launch the synchronous commands during the pass number 1, which is the Windows PE initialization. So the Windows PE is something that we'll talk in a few minutes, but Windows PE is used for the installation of the operating system onto your final target. Pass number 4 for the specialized step. Pass number 6 for the audit user, and pass number 7 for out-of-box user experience system installation. So, okay, I can run a command at a specific step of the installation of my operating system. I can run more than one command. You can add multiple entries for the pass number 4 if you have different drivers to install on your operating system. So the idea is to say, I have a package. I want this package to be installed during the pass number 4, for example, the specialized type. The thing is, when you have those packages and you are installing those drivers or applications, it may require some user interactions, just at least to follow the wizard, the installation wizard. Most of the packages that you get that have a wizard have a silent mode option. This silent mode option will select by default all the options of the wizard and will not request any inputs from the user. So by looking at the package that you want to install and by probably sending questions to the provider of this package, you can identify the silent mode options that can be used to install automatically this package. The MSI file, for example, can be installed silently by launching MSI exec. MSI exec. When you are a user, you are browsing to an SI file, and you are just double-clicking on the file, and the file is installed automatically. But if you start a command line application, a command line console window, you can type MSI exec space and few options on the name of your package, and then it will install automatically your package onto your machine. So we are going to do the same on Windows Embedded Standard 7 during the installation of the operating system. So the first thing to do is to add to the distribution share your package, because the ICE tool is building a set of files based on the content of your distribution share and the content of your answer file. If you don't add this package into your distribution share, then you won't be able to add those files inside your installation package. So the first step is to create a new folder inside your distribution share $OEM folder. The same way we did it last session to include your application. Inside this folder, you will drop your your installable package and a batch file. And inside this batch file, you will have the commands to be executed on your operating system to install this package. And this is really important to make sure that this batch file is really well wrote, and you are sure that the content of the batch file is really installing the package onto the target. Once you have this batch file, sorry, I'm going back to the previous slide. Once you have this batch file written and available inside your distribution share, then you can create a new synchronous command entry that will point to this batch file. The idea is to have all those files installed automatically then onto your target. Okay, so there are some applications like virtual machines, like Adobe Flash, Reader, TeamViewer, Office Viewers, lots of different applications that could be nice to have on your final product. But all those applications are quite complex to install. There is a lot of different options to select, to different features to be downloaded, different set of files to be downloaded first before being able to install this package or those applications. There is a project onto the web, onto the internet, called the Grid Unattended Project, or TGUP. So on www.tgup.net you can find a set of unattended package installation configuration files. Using those packages, you can directly have access to Java in your on your final target, which avoid time-consuming spent on trying to have something running onto your final product. Okay, so this is for the application installation, but also for the drivers installations. It works for both. Now, probably you have an operating system that will be accessed by different users. Probably your users are not really familiar with Windows, and you don't want your users to be annoyed by any Windows-specific dialog boxes, for example. Or your system is not accessible via a touch interface or a mouse. It's just a display panel. And you don't want to see that type of screen onto your product. A dialog box that comes from the operating system, not a dialog box that is coming from your application, because it makes no sense to develop an application that displays dialog boxes when your user have no way to close those dialog boxes. So Microsoft introduced in Windows Embedded Standard a component named message box helper, or message box filter, sorry. This message box filter is a component that will allow you to automatically close dialog boxes when they are displayed on the screen, and will allow you to log all those dialog boxes into log files that you will be able then later to analyze to see what type of errors occurs onto your target. Because the message box can be showstopper on any kind of devices, you want to avoid that type of information to be displayed to your customers. So the message box default reply component will allow you to automatically close those dialog boxes by selecting the default button. Every time you are displaying a dialog box into a screen, you always have a default answer, which can be usually accessed by pressing the space button or return directly. It can be a dialog box with multiple buttons on it. We are really talking about dialog boxes displayed by the operating system with notifying you of errors or describing, yes, mainly errors with different types of buttons. Yes, no, cancel, okay. So with this component, nothing will be displayed on the screen. No dialog boxes will be displayed on the screen. No operating system dialog boxes will be displayed on the screen. So that means that no modifications of your application is required. No needs to do some custom developments for your Windows Embedded Standard 7 targets. Your application will run right onto the Windows Embedded Standard 7 target, and the default reply will be applied to all those dialog boxes that could show up for your users. All the content and the title of the dialog boxes will be logged into log files that will be accessible later on when you will do some system debugging. Okay, so this tool is provided with an additional tool called the dialog filter. This will allow you to, for some specific dialog boxes, to not answer to the default actions, but to answer to a specific button of the dialog box. And everything will be recorded inside a configuration file that will be provided to the operating system. So with those dialog box filter, you will be able to hide the fact to your user the fact that you are running Windows on the target. And for sure, you won't see any error messages displayed on the screen to the user. So also your application should be able to handle all types of errors to make sure that the system won't stay locked into a state that the user won't be able to interact with it or won't receive the information that the device should provide to the final user. Now we have to talk about Windows PE. We just talked briefly about that at the beginning of this presentation, that the Windows PE is a lightweight operating system based on Windows kernel. This is something that is mainly used by IT members for administrations of the desktop machines or the servers, because it's an operating system that could be used and is able to detect hardware, to capture the content of a hard disk, to clone the content of a hard disk, to customize a setup. So this Windows PE tool is also used by the tool that will install the operating system onto your end target. The tool that installs the operating system onto the target is called Image Builder Engine. So every time you are building a Windows Embedded Standard 7 image, it will include the Image Builder Engine and all the files required for the installation of the operating system. And this tool is running under Windows PE. So when you are building a bootable media for Windows Embedded Standard, it will also include the Windows PE operating system. So Windows PE is a subset of the Windows API. It is containing a subset of the Windows API. So that means that some basic applications can run onto Windows PE. You don't have access to the .NET framework. This is not something that is currently supported. But at least you can build a small application that will allow you to connect to a remote server, doing FTP, or configuring, give you the access to the network interface, being able to configure the IP addresses if you are not using the HCP, for example. It can also load some drivers, so Windows 7 drivers. And it has some additional APIs that gives you access to the ImageX file format. So ImageX is a tool that will allows you to capture the content of a hard disk and to deploy this capture onto another hard disk. This is really useful on manufacturing. For example, you will have your final targets ready. You will capture the content of your targets and you will be able to deploy this content to your devices on the production line using that ImageX tool. There are lots of different other competitors' applications, but this ImageX application is something that is provided by Microsoft, and it's included inside the development tools, and it's accessible for free. I don't know exactly all the terms of the licenses, but yes, it is provided inside the development tools. So this Windows PE application or environment, can be customized. So that means that when you are building a bootable media hosting Windows PE on it, you can customize the content of this bootable media. You can add your own application. You can start custom scripts to automate for example, the installation process of captured runtime image onto a target. Creation of the hard disk partitions, formatting, network access, and so on. So this is really a powerful tool that you can be used to automate some tasks, some actions. So this Windows PE tool can be used, will be used by the development tools for the creation of the bootable media for the operating system, but can be used also for your maintenance and all your development process. When you are building Windows Embedded Standard 7 targets, probably you are focusing on the life duration of the product. If you have a hard disk, the life of a hard disk is quite long. There is a lot of it can support a lot of different read and write access by sectors. But when it comes the time you are selecting a different type of media that have flash, for example, like SSD or compact flash or SD card, you can have a system booting on an SD card. Then you have a limitation in terms of the numbers of write access onto those media. So you are not sure that the life of your product will be the most appropriate if you are using that type of media on using a Windows Embedded Standard 7 operating system. So you have to think about this when you are building a Windows Embedded Standard 7, because Microsoft is providing some embedded features that could be used to enhance the duration the life duration of your product. And one of those tools is what we call a variety filter. So the goal of a variety filter is to be located between the storage and your applications. And as it is a write filter, it will filter all the write accesses. So the idea is, instead of writing the data directly onto the storage, it will perform all those write access into a RAM area, RAM memory. So no longer write access to the storage. But if it's in RAM, then you can think about the persistency. Because if it's in RAM, then your write won't be persistent between system boots. So you have to think about that. Your storage will be protected. You will not physically write the content, the modified data onto the storage. It will be written in RAM. But in the other hand, you have to make sure that the modifications applied are finally committed to the storage at the right time, probably before rebooting your target. So if your system is using an enhanced write filter using RAM file system, then RAM option, then all the write operations will be operated in RAM. So when you enable the EWF or enhanced write filter, you will be able to protect a disk or a partition. The EWF will reduce the amount of write cycles performed on the flash media. And all the modifications applied to the file system can be committed at once. But as the EWF is not writing the data onto the storage, it's writing the data onto RAM, then you will need more RAM onto your operating system to make sure that you will be able to store lots of different modifications applied onto your hard disk. There is another filter available for Windows Embedded Standard that will be more flexible. That will not filter for a partition, but filter by files. So that means that you will be able to protect the storage for the write access of some files. All the write access for the protected files will be performed inside RAM, and for the other files it will be performed onto the storage. So if you are protecting a specific file, then all the access will be, write access will be done in RAM, and for the other files remaining onto the system, then it will be done on the storage. So it's more accurate. You can really customize what are the informations that are for you mandatory to be stored onto the storage and not in RAM, because you cannot, your product is must have those informations valid on every boot. So if it's in RAM, then you are losing the previous modifications. You have no persistency. If it's on the storage, you have persistency. But on the other hand, you have to make sure that all those write access will not reduce the life of your flash device. So if we resume about the file-based write filter, it allows you to protect file systems and folders. You will provide a list of unprotected files. And all the protected files, write access will be performed into RAM. Now you can mix the write filters with another technology, which is the hibernation. Before talking about the hibernation, we have to talk about the write filters. So the write filters are accessible from a different set of APIs. So Microsoft is providing a small SDK that will allows you from an application to enable those write filter by directly accessing the APIs. All those APIs are located in a provided DLL, so you don't have to care about how it is done. You just have to get access to that DLL and call the correct APIs. But Microsoft is also providing a command line application that allows you to from the command line to manage those filters. Basically, this this application provided by Microsoft is relying on the DLL that you can access from an application. So all the actions that you can do from this command line application will be accessible by APIs in your applications. Okay, so you have a lot of different help information onto the Microsoft website. So we can associate the white filtering and the hibernation, and the mix of those two will allows us to enable Home, hibernate once, resume many. The goal is to always start your device from a hibernation file. So on every boot, the system will boot from the same hibernation file. An hibernation file is a snapshot of your system at the time you create the snapshot, or you create your hibernation file. It stores onto your hard disk the complete RAM state, all the open applications, the drivers enabled, unloaded, and so on. So every time you will boot, you will always resume from the same state. So that means that your system do not have to reload all the drivers, do not have to initialize all the services and then load your applications. So you will be able to speed up the boot process of your system. So it really depends on the type of devices that you have, on the amount of RAM that you have on your device. But if you have a small amount of RAM and a small set of drivers, then you will be able to resume in a really quick, short amount of time. But when you are enable Home, it may require some application modifications, because all non-protected file system must be unmounted on Hibernate. So that means that if your application is accessing a file onto your hard disk somewhere, and this hard disk is not protected with a filter, then your application at every boot will have to reopen that file to make sure that the file, as it is, the file system is not protected. The file content may change between different boots. So your application must have to reopen that file to ensure that the access to the file is correct, and the file is still accessible to the device. Yeah, so the presentation that we are showing today will be recorded and is recorded, and we will drop a sample video that show how fast the system can resume from home. This is something that we cannot show directly with this live meeting session, but this is something that we can show later during when the video will be accessible. Okay, so we reached the content of the training today. Thank you for participating to this session. The next session will focus on the maintenance and update of your operating system. So we will see how we can deploy an operating system, update onto a running system, how we can install additional packages, or we can perform some application update, and what kind of tools are accessible for device management. If you have any questions regarding those technologies, please feel free to contact either Arrow or Adeneo Embedded. You have all the email addresses available on the slides that we show today. So thank you for attending this training, and hopefully we will see you on the next session. Bye.